Welcome back everyone to the Sansui 907MR. We are going to get started on this. We're going to dive straight in. Hopefully you've seen the previous video, but we're going to be giving the amp modules a once over, changing the trim pots, having a look at the capacitors, seeing what else we can do. Oh, and also the thermal interfaces. Oh yeah, also just checking for glue on the PCB. I don't think it's an issue on this model, but we may have some to deal with, so we'll find out. We have our parts here, got some new thermal paste just in case. Not planning on using it. I want to use these very expensive sill pads from Burkhorst. I think that's how you say it, K10 pads. 20 of those in there, got 4 spares in case we need them. Yeah, so we're going to get started on this. I'm going to try and tip this thing over, work out how to get these amp modules out, and we'll just sort of try to time-lapse something. I've got to be really focused on this, but I'll try and get some video. The first issue I can see, this faceplate isn't flush with the side. It actually sticks out, and the clips on the top are plastic, but it also has Teflon tape covering everything, which I don't really want to mess with. I have a feeling I'm going to have to remove it one way or the other, but I'm going to leave it for now, and I'm going to just sort of chock up the amp with some folded up rags to try and get the weight off the edge of this faceplate, because it's a lot of weight for this to take on one end. So anyway, let's get started and see what happens. Oh, heavy. Woo. Hey, that's not bad. That's not bad. I think there's decent gap. Stay. All right, so the bottom plate is off. Just having a bit of a look around. Lovely copper chassis, copper screws everywhere. This power supply is wild. I have to have a look at this and see what's going on later. Dual rectifiers. There's a fuse hiding in there, and I have no idea what's going on with these transistors. Oh no, D5, so that's a diode pack. Interesting. Yeah, I don't know what's going on in here. We'll have to have a look around later. So yeah, anyway, let's get this amp module out. The only problem I foresee is this bitumen's wedged against the heatsink and it has to slide out the top. I'm hoping when I remove these 4 mounting screws, I can sort of just drop it down onto this plate and have enough clearance to just slide it out. We will find out. Future reference for me, future me, there are duplicates colored wires in here, so I've got to pay attention to that, putting it back together. But if I leave this cable tie in, hopefully the wire memory will keep me roughly where I was. Anyway, let's see if we can get this out. Okay, not as easy as I thought. This wire loom does seem to be going to the amp module also, and you cannot get to it. So I am really hoping that this can be disconnected on this end. We're about to find out. And it can be that one. All right, so that should hopefully get it out. Four. Okay, amp module is out. So basically we've got 4 really long screws that sort of just sort of slide in and mount it to the chassis. So you remove all those out, and you can slide the whole module. Now, this module is really interesting. There's a lot going on here. So we've got the 4 trim pots we're going to attempt to change. I have to be careful with these and inspect them carefully. Make sure to set the new trim pots to what these ones are. The service manual is not correct for these trim pots. There's a couple of them, they're labeled as 1 ohm. And I went and cross-referenced another service manual for the previous or the next model. I don't know what it was, but it said 1K ohm. So I've ordered all these trim pots blind because I'd have to remove them to test. So yeah, I'm hoping I got the right ones. We'll find out. These capacitors are just monsters. We've got raking resistors everywhere. I think they're raking. The orange ones, the blue ones. Yeah, there's a lot going on here. These capacitors have definitely been knocked around a bit. This one's really off center. I might try and get these flush with the PCB once I get it apart. And we'll have a look at these closer as well. There's no glue to speak of that I can see. So I guess they decided to abandon it at some point, which is interesting because they did use glue on the earlier models. Fascinating. Anyway, I know a few people were saying not to redo the thermal compound and leave it original, but I can't get this board out without unmounting the outputs, which means we have to redo them anyway, so we're redoing them. The only other interesting thing I've noticed is normally the outputs are insulated electrically from the heatsink, and these are all screwed onto a copper plate, and the copper plate is bolted directly to the heatsink. So I am not sure what's going on here, if they're already isolated, but normally they pick up off the screws and they have like insulators inside, but I don't, it'd be interesting to see what's underneath this. So yeah, let's start demounting the heatsink. We're going to clean it all up. We're going to do the trim pots. We're going to have a look at some of the capacitors and keep going. Got it out. I had to sort of move the outputs, and then I was able to use a bit of leverage to break the suction and get them off the heatsink, so that was fine. The sill pad idea is still going to work, I think, but there is a little hiccup in it, in that these heatsinks have a copper distribution plate to help dissipate the heat over a larger surface area. And I don't really buy into that this makes much of a difference, but it's here anyway. But you can see they're not mounted to the heatsink in any meaningful way other than the thermal paste. So we have the output transistors with thermal paste onto a mica insulator with more thermal paste onto this distribution plate with more thermal paste onto the heatsink. Wowzers. So yeah, it's going to be interesting. We'll see what happens. We have what appears to be some sort of thermal balancing or compensation in the middle here, one for each channel. So I'm assuming that's doing some sort of temperature drift to help keep the bias in check or something along those lines. I am glad I removed this because the thermal paste is garbage. You can see how dry that one is. There's barely anything left. Some of these look okay, but overall, there's that one as well. There's barely anything left. This is what I see on a lot of amps, and I recommend people do this as part of a restoration if you have the means to do it. Just redoing the thermal paste. Thermal paste is cheap. If you can generally save the mica insulators if you're careful, and you can improve the thermal performance and the consistency by doing this, and you stop like one output running really hot while the others are running cooler if one happens to dry out. So one micro insulator here you can see came off with the transistor. Yeah, so I think we're going to, what are we going to do next? I'm going to clean up the heatsink, I think. We'll get everything prepped for reassembly. We're not going to do it yet, obviously. And I'm going to try and straighten this one because it's really annoying me. Okay, so the plates are moderately clean. Just been pondering putting this back together. For some reason, one plate was this way, one plate was that way. Now these look like they're just sort of die cut pieces of metal. So one side is sort of rounded off because that's where the dies punch through the metal, and the other side has like a, see on this one, it's got like a lip on the edges, which I think you can hear my nail catch on them. Yeah, so that sort of stops it seating properly. So I'm going to just sort of sand down these edges like I've done on this one, and it's all good. I'm not going to do it on camera, but I just thought I'd show you that I'm just sort of cleaning these up. And I don't know why they weren't both placed in the same way. Like, yeah, one upside down's a little weird. Anyway, probably doesn't make much difference, but I'm just want it to be consistent. And yeah. All right, we're going to get stuck into the amp module now. I was just doing a bit of a test and trying to clean up these outputs a little bit. So you can see these are definitely fully copper, but you can see how much they're tarnishing. Doesn't really affect thermal performance that much, I don't think, but we're just giving it all a clean. So I just gave a bit of a scrub with some steel wool, trying to be very careful because you end up with steel wool fibers everywhere. Yeah, so I think that'll work. Also interesting, and I don't know if I can show you or not, it appears that the feet or the legs are copper as well, which is just really cool. Yeah, so I'm going to finish cleaning these outputs and then we're going to tackle those trim pots. All right, got the board set up in a little work holder so we can get started on this. We're going to do the trim pots now. I'm going to start with this one. We'll take it out. I'll do the measurements and everything, and I'll show you how I normally do the swap out process. Hopefully we've got the right ones, and I'll just do the others in a time lapse. You don't need to see it over and over again. Save some time. Okay, so the first trim pot is out. Just having a bit of a look. Now on this one, you probably can't see it here, but the two opposite ends of the pot are joined together on the PCB. So we have to set the adjustment that way. But what I normally do, just as an FYI, if I'm replacing a trim pot, I'll normally measure opposite ends of the wafer. So that gives you the total resistance of the trim pot. And in this case, it's 387-ish ohms, and it's supposed to be 470 according to the service manual. And I do see 470 printed on the bottom of this. So it seems like it's just quite a ways out. It was probably like a 20% tolerance or something, which is a fair bit. So anyway, what we need to do with this one is to clamp both legs somehow. Can be a little bit tricky. and then measure the wiper. And this is a little messy, but come on, baby. 93 ohms, which is what I've got written down here. So we basically need to set the new Burns trim pot to the same. So we'll check that as it is. And we're at 102. And we'll dial that down to 93. Give it a scooch. Come on. Even with a multi-turn, they're still pretty finicky. That's good enough. Yep, so that's all we need to do to put the new one in. And yeah, there's one other issue on the board, which I just found, so I'll show you that and we'll keep going. Now, while I had that trim pot out, I noticed there is actually a little bit of glue. Doesn't appear to be on any of the others, but for some reason, just this one. And it was put on very sparingly as well by the looks of it. But we're going to take that out because I'm a little bit worried it's underneath and it might be corroding the legs of this Silmic. Yeah, so we'll take that out, fix this, then we can put the trim pot back in because it's right next to it. So I'm using toluene to hopefully dissolve the glue. It's worked on every other glue I've used, but as you can see, if I zoom in here, it's not really an issue. You can see it's clear of the legs, but it's not good to leave this stuff in there. So we'll get rid of it while we've got this apart. Normally, after a couple of minutes, the toluene sort of turns this stuff into a gel. Or maybe not a gel, but I don't know. It just seems to sort of peel off after a while. And hopefully, it just comes off without too much effort. And I can't see any more except for the opposite end, because it's sort of a mirrored configuration. So all the other caps look clear. So doing a bit of capacitor investigation after cleaning up the glue. All the glue is gone. PCB's in good shape still. Didn't scratch it up too much, so I'm happy there. Yeah, I got this Silmic capacitor out, and I was just having a look at the ESR and the capacitance. So 474, and it's 470 rated. That's excellent. Pretty much bang on for a capacitor, actually. If I measure a new Silmic 2, 466, you know, it's in the same ballpark. ESR is basically identical. And then we've got a Panasonic FM here, and that's way under. Well, it's still good enough, but it's under. So yeah, ESR is identical as well, but physically, size difference. The FM's like half the size of these Elna Silmics. So this is a 35 volt, so it's going to be a bit smaller, but I'd say that's about right for what it is. But there was one other thing I've noticed looking at this much more closely. We have Silmic capacitors here, and then we have these other ones, Super Gold Silmac Alpha. So I'm assuming this amp is stock. I don't see any evidence that it's been messed with, but these are not Alpha Gold. These are still very special, but there's something about these Alpha Golds that's dramatically different. So this is like 50 volt, 10 microfarad, and this is 50 volt, 470 microfarad. So this is 47 times the capacity. But physically, there's not much difference between them. Like, that's 0.5 centimeter, if that. So I don't know what is going on inside these Alpha Golds, but they are built to a very different design than these ones. Yeah, I just thought I'd share that. I don't know what the deal is, but we're just going to keep going with this, reassemble this area, put the trim pot back in, do all the other trim pots, get rid of the glue on this capacity here, and get this thing reassembled. So I decided to pull out one of the Silmic Alpha Super Gold capacitors, and I'm just having a look at it, and the ESR is nuts on these. So 0.1 ohm, you know, 10 microfarads, so that's all fine. But I also noticed the leads are copper as well. I don't know if you can see that. So that's another big difference. But, you know, if we compare that to say a Nishikon PS, 2 ohms. And we've got a Panasonic FC here, I think, which is a pretty decent one as well. Get that on there. 1.25 ohms. So these are very good. I've never seen a capacitor perform this well at such a low capacitance value with ESR, and they're very bloody heavy. So, you know, you compare this thing to all the others, big difference in size. So yeah, can see why they're not used very often. Yeah, thought that would be interesting for people to know. I know I said we were going to keep this restoration to a minimum, but I just can't help myself sometimes. And this was a lot of work to get out, so I don't want to be coming back in here for a while. So I decided to reflow pretty much this entire board except for the output section, because there was too many questionable solder joints that either didn't have enough solder, had what looks like dry joints beginning with little ring cracks starting to show up. Mainly that there just wasn't enough solder, in my opinion, from what I could see. And I have this board out, so we're going to do it. So I'm pretty much done here, reflowing it. Now I'm going to wash all the lacquer off so I can do a proper inspection and make sure I haven't done anything that's going to cause us problems. So yeah. All right, we're done with this board. I've reflowed every joint. I've washed the lacquer off. I've trimmed a lot of leads. I don't understand what is going on with this model. They leave all the lead lengths really long, and they could potentially push over and short on something else. So that's all the old lacquer plus some leads, and I've just sort of trimmed it all down to clean it up a bit. Gone over it with a fine-tooth comb, and I cannot see anything that should be a problem to reassemble it with. So we are going to put this back together and test this channel out. It's just one thing after another with these projects. I don't know how they managed to assemble this thing. So, you know, the right plate lines up really well. There's no issues there. This left plate, however, did not line up very well. They must have cross-threaded the crap out of these screws to fit this in. You can see there that they line up, but I had to open up these center holes to the left with a deburring tool to get this, you know, to find the holes again. Giggity. So, yeah, another problem fixed. Now we can keep assembling this thing. Okay, so the amp module is back in. I've tested it and we have no fire. And yeah, it was way out of calibration, even though I was quite careful. So you definitely need to pay attention to that. On the back of the board, you really need to check the circuit traces for each trim pot and make sure that if two legs are joined on the trim pot, you need to adjust it with those two legs shorted. And it's quite a bit different from most amplifiers I've had to work on. So yeah, we're done with this amp module. We still have the other one to do. I'm going to just do that off camera because it's the same process. And then in the next video, we're going to do the preamp, which I've taken the front cover off just to have a look. There's only 3 screws, so it wasn't anything interesting. So we're going to change those 2 trim pots. We're going to calibrate that as well. So we're going to pull this out in the next video, calibrate this, calibrate the rest of the amp, and I'll take you through the whole process. I had a quick stab at it with this amp module already, and I think I've got a rough idea of how to do it now. It is quite unusual, so I will show you how that works. I was just checking the old amp module that hasn't been done yet, and it's way out of calibration. So this should be under 30 millivolts on the DC offset. We're over 200. Where the one I did was like over a volt, even though I was really careful adjusting the trim pots when I was putting them back in. So I don't know if that was way out of spec from the beginning. I probably should have tested it first, but live and learn. So yeah, this video is already way too long, so I'm going to close this out here, get this other one done, and we'll be back with the next video in this series. Hope you enjoyed what we've done so far. I'll see you in the next video.